Okay, so the next two sections, 4.2 and 4.3, is going to be you showing triangles are congruent. And there's four ways you can show them. The first way is using the side postulate. So what that says if you have three sides of one triangle congruent to three sides of another triangle, then you know those two triangles are congruent. So side means you need to have all three pairs of sides congruent to each other. So what you're going to find is in these next two sections you're going to have to do some more proofs. And like I alluded to in section 4.1, there's a little bit more of a process, so you know what you have to look for. It has to fit one of these four theorems that we're going to talk about. So for example, on this first one, I'm given these sides are congruent to each other, and those are marked over here in your picture. So the first thing I would write down is the given, always, okay? Now, I'm trying to show these triangles are congruent to each other. So I either ask myself, how would I show they're congruent? Or, is there anything in the picture that I do know is congruent? Well, right off the bat, I see that I have two triangles butted against each other. I have this triangle on the left, and I also have this triangle on the right. Notice that they share this side. Well, I'm always going to be congruent to myself, which is why I'm going to write that next statement. So Ln is congruent to Ln. When I'm congruent to myself, that's just the reflexive property. Now notice that I have all three sides congruent to each other, so automatically I can say those triangles are congruent, and I would use the side postulate that we did up here at the top. Okay, the other kind of postulate that we're going to use today is side angle side. And what that says is if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. All of that is saying I have this side and this side congruent, I have another pair of sides congruent. The included angle means it has to be in between the two sides that are congruent. So this is an included angle because it's in between my two sides that are congruent. Okay? So side angle side, just from the way that's wrote, side angle side. The angle has to be in between the two sides that are congruent. So let's take a look at our next example. So on my next one, it's asking what other information do you need in order to prove those triangles are congruent by side angle side? Well, right now, if I look at my picture, again I see two triangles butted next to each other. So I know that DF is congruent to itself. So I have taken care of the two sides. Now, I need an angle in between those two sides that are congruent. So think to yourself where that angle would be. Well, here are my two sides, so the angle has to be what's made up if you were to make those your rays of your angle. So I would say angle EFD has to be congruent to FDG in order for me to show that they're congruent by side angle side. Pause the video and try the next question. So in the next one, it asks, what do you need to prove these triangles are congruent by side angle side? Once again, they've marked two angles congruent, so I have one pair. I know that LB is going to be congruent to itself, so I'm going to go ahead and mark that as well. In order for me to use side angle side, I have a pair of angles, and I only have one side. I have to have another side, and here's the important part. Remember that your sides are the rays of the angle. So here is one ray of my angle down here. So if I were to extend from the vertex out the other way, this side in B would have to be congruent to LE because those are the sides that are going to make those angles included. So that's what I wrote down. So be very careful and make sure you know that the angle has to be included between those sides. That's why it's wrote in between the sides in the name. Alright, let's take a look at a couple more. It's asking, would you use side, 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 or side, angle, side to prove the triangles are congruent? If there's not enough information to prove the triangles are congruent, write enough information and explain your answer. So here's angle 1, or question 1. What I see right off the bat is I have two pairs of sides and I have an angle. The angle is in between those two sides, so I know that that one would be side, angle, side. And if I had to explain it, it'd be because I have two sides and one angle congruent. Here, I have two sides congruent. I have an angle that's included here, but this angle over here is not included. That would need to go right here in order for me to be included. So this one is not enough information because the second triangle is not having a congruent angle in the included spot. Alright, you're going to pause the video and try the last two. So in the letter C, I put side, side, side because I had all three pairs working together there. And then in letter D, I have all three sides congruent, and I also have these angles congruent. So you could have put either one because all three sides are congruent, and I also know those angles are congruent and they're included, so side, angle, side. So either one will work on that last. So tricky part on this is just be aware that the side, angle, side, the angle has to be in between the two sides. So making sure you always see the two sides making up the rays of that angle.